So just like the last problem, we're gonna remember the same thing, right? So remember this is like f of x, and scribble this in there real small, a times x minus h squared plus k. And remember that the vertex is h comma k, but what is that? Well, this is a plus 2, but the formula has a negative. So what is h? Yeah, negative 2. Very good. Right? And that makes sense because when you minus a minus, it becomes a plus, right? When you minus a minus, it becomes a plus. So you got to remember the h is always the opposite of what you see in the parentheses. And then k is just whatever k is, right? So that would be negative 4. So we're going to plot the point. We're going to go negative 2 down 4, and I'm just going to plot a point right here. Negative 2, comma, 4. And so to finish this, I'm going to say, I'm going to do my little grid like this. X, comma, y. And I think when this is 2, my y value should be 4. Right? How can I double check that? My calculator, right? So on my handy dandy calculator, I'm going to clear everything out. Just hit clear a bunch of times. I wonder if you just hit delete. Yes?
Would it go up, or why is it going down? The y is positive.
Oh, yeah, you know what? That's a negative 4, isn't it? Good catch. The question was, Mr. Adams, why did you write positive 4 if it's negative 4? I think.
Yeah, I was like, are we going down?
Why are we going down? Yeah, it's negative 4. I just forgot to put the negative sign. So see, remember how I said it's always a negative symbol, and even I forget it sometimes? It's always a negative symbol. All right, let's double check it. So what I'm going to do is I'm going to plug this in the calculator. I'm going to say 3 times the quantity. For x, we're going to plug in negative 2. Now, this is going to be confusing because you got to remember when to use a negative and when to use a minus. If you get an error message, like it says syntax error, you use the wrong symbol. Now here I got to say subtract 4. Enter. It does equal negative 4. So now what I want to think is, what number is 1 unit? So also, before I get ahead of myself, I know that if this is the vertex, right? So this is the vertex, then that means that I have a line of symmetry, a vertical line of symmetry that goes through that point. So really, you only have to plot one side of the graph. Also, 3 is positive, right? So because 3 is positive, how is that going to open? Up or down? That's going to open up. When a is positive, remember when a is positive or greater than 0, it opens up. So I'm going to have my U shape like this. Okay? So I want to pick a point that's pretty close to negative 2. So what I'm going to do, I'm going to change red. You can see the red a little better. I'm going to plug in negative 1. So I plug that in my formula, so I'm going to say 3 times the quantity, negative 1 plus 2, close parentheses, squared, minus 4. And so when I plug in negative 1 into the equation, it spits out negative 1. So this point right here exists on the curve, negative 1, comma, negative 1. Now, since that's 1 unit away from the line of symmetry, I should have another point over here. In other words, when x equals negative 3, my y value should also equal negative 1. How can I verify that? Plug it in. So I'm going to say 3 times the quantity. What am I plugging in for x? Negative 3 plus 2, close the parentheses, square it, minus 4. Hit enter. It does. It equals negative 1. Let's try another number. How about we try 0? Let's see what happens when x equals 0. So I'm going to say 3. 3 times the quantity, 0, plus 2 squared minus 4. And I think it's 10? No, wait. It's 8. So this is 8. So right up here, I've got this point right here. Now, this is the point 0, comma 8, which makes sense. All right, so now what do I do? Well, I think since this is 1, 2 units away from the line of symmetry, if I go 1, 2 units on the other side, this point here, which is actually negative 4, comma 8, should also exist on the curve, right? How do I double check that? Plug it in. 3 times the quantity, negative 4 plus 2, in parentheses squared minus 4. That also equals 8. So yeah, that worked. So now let's try that on Desmos. So I'm going to change my formula. Let's close this formula out, and I'm gonna delete all these. I'm just gonna delete all these. Don't delete the whole thing though. So when x was negative 2, what was my y value? Negative 4, right? I'm just looking at my calculator, negative 4. When x was negative 1, my y value was also negative 1, right? When x was negative 3, my y value was also negative 1. When my y value was 0, let me catch up to my calculations here. My y value was 8, and then when x was equal to negative 4, when I cranked through and did the math, I had a positive 8, right? So those are all those plots that we just plotted on the graph. Okay? Let's graph it and see. So we said that y was equal to 3 times the quantity, x plus 2. Actually, let's do the same thing that we did last time. In parentheses, do x squared like this. So that's the parent function. Okay? That's the parent function. I'm going to do it a little different, though. I'm going to put in the hk first. So this was plus 2. Now, you could do it like this, minus minus 2. And notice that it shifted it over 2 units to the left. But what we wrote in our formula was just plus. Whoops, was plus. Okay. And then on the outside, what was our k value? Minus 4. We're not quite there yet. So the 3 is going to stretch that vertically. It's like, think of Play-Doh or bubble gum or silly putty. When you pull it this way, it stretches it, but it also makes it skinnier. So that's what the A term does. When I plug in 3 here, boom, there it is. And I'm going to switch these around so we can Well, maybe I can't. Is that time to go? No, not time to go. We have plenty of time left. All right, are there any questions on this? Oh, no, I wanted to